Alright guys, today we're going to be talking about, we're on 8.4, we're talking about multiplying and dividing and just simplifying rational functions. So let's think back to like 5th grade. And let's think of simplifying fractions. So my daughter's doing this right now, we were just talking about it the other day. We're going to simplify just a fraction. So say I've got 12 over 15. I know they can reduce, and we don't even really think about it. We know it can reduce by 3, because they're both factors of 3. So we just say 3, I'm just going to kind of write this out. So 3 times 5. So I know 12 is 3 times 4, and I know 15 is 3 times 5. Well, let's see if I can fix that a little bit. There we go. If we think about, we can separate those. So it's 3 over 3 times 4 over 5. We're just kind of thinking through this a minute. Well, anything over itself is 1. So 3 divided by 3 is just 1. So I've got 1 times 4 over 5, and anything times 1 is 4 over 5. So we don't even go through all of those steps to simplify it. We just get from here, we know we can reduce by 3, and then jump to 4 over 5. But for what we're doing today, kind of seeing the process is important. So this multiplication here, we're able to separate it and cancel those out. If we think about, let's kind of go back to that same example. I also know 12 is the same thing as 10 plus 2. 15 is the same thing as 10 plus 5. Can I cancel out those 10s? Can I write this as 10 over 10 plus 2 over 5 and say, well, that's equal to 2 over 5, because that's a 1. Or actually, if I was being technical, that'd be 1 plus 2 over 5, so 1 and 2/5. Can I do that? Are these two things the same? Because if they're both true, then those numbers should be the same. They're not. Well, notice we don't add fractions that way. We have to have a common denominator, so we cannot just separate these and add them. And you're kind of looking at it going, that doesn't make any sense. Why would anybody do that to begin with? But when we're looking at problems involving x, many times students will want to say, well, x plus 1 and x plus 2, well, these x's can reduce and I get 1/2. Well, that's not true, so that's a big no-no. And this one here is a big no-no. So we don't do this. We can only simplify if we're multiplying. So our first example would be, so I've got 2x plus 1 divided by x plus 3 times x plus 1. Okay, so if I'm looking at these, I've got 2 times this thing and x plus 3 times this thing, so I can separate those. Like I said, that's 2 over x plus 3 times x plus 1 over x plus 1. Now this is 1. So I can say that's 1. So those cancel each other out, and all I have left is 2 over x plus 3. And so that would be our answer. Okay? So we're able to reduce those just like we did with these fractions up here. We're able to basically reduce those. So let's look at another example. Say I have 40x plus 20 divided by 10x plus 30. If I look at those, nothing's being multiplied. So what I'm going to do first is factor. Just like I did up here, I'm going to factor those out. Basically, we can just factor it out as much as we can. So here I can factor out a 20. That's going to give me 20, and I've got x plus 2. And down here, I can factor out a 10. Oh, I did this wrong. That's not right. If I factor out a 20, I get 2x plus 1. Down here, if I factor out a 10, I get x plus 3. Now these are not the same. I can't cancel those, but I can still reduce these numbers. So 20 divided by 10 is just 2. So I'd have 2 over 2x plus 1 divided by x plus 3 would be my answer. Okay, so we're going to simplify them, we're going to factor them out as much as possible, and then we can reduce them. Say I have, let's do another one. So I've got 4x over x squared minus 16. Okay, again, I cannot cancel these x's. I cannot reduce this 4 and 16. But I can factor this. Remember, this is a difference of squared. So I've got x squared, and I've got 4 squared. So I can write this, again, that's x plus 4. I've got that as x minus 4 times x plus 4. Now I've got this x plus 4 on top and bottom. I can cancel those. Now, this has got to stay in the bottom. So it's going to be 1 over x minus 4. Okay? So this is basically like a 1 times that. So these will cancel, and I've got a 1 left up here. Now for multiplying fractions, let's think about that for a minute. Piece of paper. So let's look at some examples of multiplying. Remember back in 4th grade, maybe even 3rd grade, I don't remember, when we'd multiply fractions. We just straight multiply across the top, multiply across the bottom, and then reduce. So that's what we're going to do here. We're just going to multiply what we can across the top, multiply what we can across the bottom, and then see how we can simplify that. So on top, if I'm multiplying these, I just multiply my numbers. It's going to give me 18. And I'm going to add my exponent. So I've got 5 plus 1 is 6, and y to the 4th. And on bottom, I've got 8 times 9, give me 72. X to the 3rd, so it's x to the 4th, and then y squared. So now I can look at it and reduce those. These are pretty easy to reduce. Remember our exponents. If we've got an exponent on top and bottom, the same base, we can subtract those exponents. So x's, I would have x squared on top. Y's, I'd have y squared on top. Now these numbers here, both of these divide by 9. So it'd give me 2 over 8, and that can reduce to 1 over 4. Yeah. So I just put that over 4. Okay, so let's look at another one of those. So say I have 2x squared minus 10x divided by x squared minus 25. And I'm multiplying that by x plus 3, and I've got 2x squared. Okay, so we're just going to start multiply across the top, multiply across the bottom. And so if I multiply across the top, I'm going to have 2x squared minus 10x times x plus 3. And on bottom here, I'm going to have x squared minus 25 and 2x squared. So what I'm going to do now is try to reduce it. So I'm going to factor everything out, or make sure everything's factored as much as possible, and then cancel what I can. So on this, I've got this x squared, so I can factor a 2x out of that. So I've got 2x, that's going to leave me with x minus 5, and x plus 3. On bottom, this is a difference of squareds again, so it's going to be x minus 5 times x plus 5. I've got x minus 5, x plus 5, and then I've got, I'm just going to say, times 2x squared. So now we look and see what's on top, what's on bottom. They both have x minus 5s, so I can just kind of mark those out. That's an x plus 3, x plus 5, so I can't do anything with those. My 2's, I've got a 2 on top and 2 on bottom. And then I can subtract those exponents. So it's a 1 on top, I've got 2 on bottom. So that's going to leave me with 1 on bottom. So my answer would be x plus 3 over, I'm going to put that x up front, x times x plus 5. And again, if you're kind of confused on your exponents, this is 1, this is 2, so if you subtract those, you would get negative 1, and negatives always move to the denominator, so that's why it would have to go down here. Okay, so let's look at just one more of those. So say I had x plus 5 over x cubed minus 1 times x squared plus x plus 1. Okay, so in this case, like all fractions, if it's not over something, it's like it's over 1. So this piece is going to go on top. So if I actually multiply those, I'm going to have x plus 5, x squared plus x plus 1, and on bottom, I've got my x cubed minus 1. At first glance, it doesn't look like anything would cancel. But remember, this is a difference of cubes. So just to remind you of those formulas, we've got a cubed minus b cubed. It's the same thing as a minus b, a squared plus ab plus b squared. If there was a plus between them, it's basically the same thing except we just change our signs. Go ahead and write both of those down. So this is a difference of cubes. So I can split that up. Well, in this case, my x would be a, and my 1 is b, because 1 cubed is still 1. And so if I come down here, I would end up with x plus 5, x squared plus x plus 1, and then if I break this down, break the bottom down, so it's going to be x minus 1, and then here I'm going to have x squared plus 1 times x plus 1. Now if we look at it, these two pieces can cancel, okay? These are set up. These are not going to reduce anymore. So I'm just going to go ahead and cancel those. So my answer is now equal to x plus 5 divided by x minus 1. And that would be my answer. So if we can get it down to just x's, not x squareds or anything like that, we know we're pretty good. If your x squared, remember if it was x squared plus a number, so if you had like, let me slide that down a little bit so you can see it. If I had 4, well I'll even say x plus 4 over x squared.